Okay, so today's goal is I will write a direct variation equation and use it to solve problems. Your homework is the puzzle page that you picked up, but if you flip to the other side of that puzzle page, the white one, there's a side that's a puzzle, and then there's another side that says round robin. Direct variation round robin. Okay? Okay, so we are going to start on the round robin side. And within your group, okay, and if you have lots in a group, why don't you choose one in your group, okay? Within your group, you're going to divide up the problems so that each member is solving one problem, okay? And then you're going to share the problems that you shared with each other. Talk about how you solved them. We are attempting to solve them. So that doesn't mean that you're going to have an accurate answer necessarily or know how to do it. So when you get stuck, these are the sentence stems I want you to use. I knew it was blank because, so that's if you knew it. I started thinking I would do blank because blank. I think I should blank because this. Have those conversations with each other because what somebody does on one might help somebody do that on another one, okay? Okay, so I am going to give us, let's go with 10 minutes to work on that, okay? And then we'll discuss as a class. Okay, our voices are off. Okay, we're going to kind of discuss some strategies that we did, even if we didn't get all the answers, and even if some of our strategies were different, okay? So first I want you to write down the answers.
Just a little bit.
I don't think it's I'm so smart. Okay, so I want you to talk to your table about if your table has a wrong answer, let's work together to try to get to that answer. Maybe we can catch a mistake. Okay, so I'm going to give you like 2 minutes to do that. Ready, go. Okay, let's talk strategies. I'm recording again, so let's talk strategies. Okay. What are some strategies that we did? Did anybody recognize a slope or a rate of change? Okay, Abby, what did you do? You did number 3, right?
I did number 3 and number 1.
Okay.
So, I'll just go with number 3. So, for number 3, it said if 20 kilograms of chicken makes 220 servings of Southwest chili, how many servings can be made with 35 kilograms of chili or chicken? I divided 220 by 20, and I got 11, and then I multiplied 35 by...
Okay, so you found a unit rate, yes?
Yes.
Okay, so you found a unit rate for how much chili would be in, or how many servings of chili I would need for 1 serving of chicken, right? Okay, so by finding my unit rate, what was your equation you put down? Y equals
11x.
11x. So I am taking my servings of chicken and multiplying by what? 11. Yes? Okay, let's go to somebody who did number 1. Okay, go ahead, Alyssa.
It says that if an object weighs 75 pounds on Earth, it would weigh 177.3 pounds on Jupiter. So what I did was I did 177.3 by 75, and then when I did one like that, I multiplied that by 120.
So you also found the unit rate.
Yeah.
So what did you get for that? It was like
2.364.
364?
Yeah.
And that was what you multiplied, so then that you knew was your equation, right? Okay. So again, we found our unit rate, and then that becomes our equation. And our unit rate, it becomes our slope, right? Okay? Okay? All right, so now those who had this one especially was a little bit more, it was a little different, okay? Go ahead.
So now I did 12 divided by 8.5.
12 divided by 8.5. So this time you took your y and divided by your x. What does that look familiar to?
Oh,
Y's over run. Okay, so if we don't have change in y, change in x. So we have y over x. Go ahead.
and then I got 1.4116.
Okay.
I times that by 125,
Okay.
and I got 600.
So you got 600 after you multiplied by, you multiplied this by 425. Okay. So again, she found her unit rate, yes? Okay, so what would my equation be if this is my unit rate? Yeah. So I did a slightly different one for that one because it wasn't quite as. Did anybody get something a little different for that one? I was gonna say I did that a little differently. I did 425 divided by 8.5 because those were the ones that went together. Does that make sense?
Yeah.
And I have y over x. Did anybody do that?
I just
Okay.
made a table.
I'm curious why that one works. 12 is your x and not your y. So that was, I'm not saying you're wrong, you still got to process. But if I'm looking for the correct equation for that one, your process was not entirely wrong, it just got you a different way. So this would be my y over x, yes? Okay, so that got me my 50, then I could go by 50. Okay, my y over x. Okay, let's do our last one. Did somebody do a different one? Go ahead, Maddie.
For number 4, I took the 15 grams and 5 centimeters, and I divided
Did you do 5 divided by 15 or 15 divided by 5?
15 divided
Okay,
by 5, and I got 3, and then I multiplied 3 by the 12 centimeters, and I got 36.
so what would my equation be on this one?
Equation, 15 divided by 5 equals 3 times 12.
So what are you multiplying by? Because every other time it was what I was multiplying by, right? Okay, so what did you multiply by?
And multiplied
But
by 3.
by 3. The 12 was already there, yes? So what could my equation be? Y equals
3x.
3x. You also, if you switched what your x and y were, okay, and we're going to talk about that in your notes, you also could have y equals 1/3 x. Right? 1/3 of the other one equals that. So we're going to talk about identifying what your x and your y are, okay, in your notes. Because you have to be able to identify those things, okay? You have to identify which one is your independent, which one is your dependent. Okay, so let's talk that question at the bottom. How is a proportional relationship in a situation involving direct variation related? How is a proportional relationship and direct variation related? Talk with your table and we'll share. One. Okay. We're sharing. How are they related? What do we think? Go ahead.
They both have straight lines.
They do have both straight lines. Yes. If I were to graph it, I'm going to end up with a straight line. Okay. Can we be any more specific about that? How else are direct variation and proportional relationships related? What about versus you're solving the problems? Did we solve problems similarly? Matthew?
The slopes are all positive.
The slopes are all positive. That is a coincidence, but that is something that has happened on this paper. But yeah, I mean, in this case, they were all positive. But we could say they all have a slope. Yes? Okay. What else do you notice about all of the equations? What are they missing that we... What are they missing?
I'll go through the origin.
They all go to the
They all have
origin.
a y-intercept.
Okay, so what's the difference between a direct variation and a proportional relationship? Is there a difference? There is no difference between a proportional relationship and a direct variation. They're the same thing. They both pass through the origin. They both have a straight line. They both have a y-intercept of 0. There's no difference between the two of them. You guys have been solving proportional problems for years. Now we're just going to writing the equation for them. To be more specific, you're finding that unit rate, which is your slope, and you're writing the equation. Okay? Last year you solved the problems, this year you're writing them, okay? Okay, so we're going to go to your notes, so if you'll find that, and we're going to try to do this as quickly as we possibly can so we can get through this. Okay? This is not the 10 minutes for that. But Tuesday. Okay. Okay, a linear relationship is called a direct variation when the ratio of y-coordinate to x-coordinate is constant. Okay? A linear relationship is called a direct variation when the ratio of y-coordinate to x-coordinate is constant. We say y varies directly with x, so y'all read that in a couple of the problems. It looks like this, y equals mx, or you might also see y equals kx. Do y'all remember that at all from last year?
Yes.
K is just another way to write slope, except we're saying it's a proportional relationship. Okay? Direct variation equations always go through the, you already said this, origin. Therefore, their y-intercept will always be 0. Okay, so before you want to solve a direct variation equation, you want to make sure it is direct variation. Most of the time, it's going to directly tell you that. Okay, but a way for us to check to see if it's direct variation, on a graph, just look to see if it goes through the origin. On a table, I want to see if my y-coordinate over my x-coordinate is constant. Okay, so with points or a table, which are points by the way, find the ratio of your y-coordinate over x-coordinate. If the ratio is constant, it's a direct variation. Hint, the constant ratio is also the slope. Okay, so you know when we find slope, we find change in y over change in x. For direct variation, you just put a y value over an x value. And if that thing is constant all the way down, that means it is a direct variation. I'm going to give you an example in a minute, but we're just going to write down these notes first. Okay? What?
They're both spelled the same.
They're spelled the same, and that's how you spell it. Sorry. Sorry to burst your bubble. That's how you spell it. There's 2 O's in it.
I looked like a D. I thought it was a D for a second.
Okay. Okay, so moving on. We're not concerned about Miss Fraser's spelling. Okay. I'm actually a really good speller. I spell really well. Okay, I have a direct variation. Now what? Now what do we do when we have a direct variation? These are some tips for you, but we're just going to go through and actually do the examples, okay? You can go back and read these, but we're going to actually look at the actual examples, okay? So what's the deal with n? Slope, constant rate of change, constant of proportionality, unit weight. All of these names mean the same thing. All of these are the same thing. And we can also use the letter K, not just N. So they like to give you like 5,000 million words for the same thing.
Wow.
You have been finding slope ever since the first time you learned how to find unit rate. Which what? Is that 6th grade or 5th grade?
4th grade.
4th grade maybe.
Like
Yeah.
4th with the little like 10 change.
Yeah. Like,
I'm confused.
I don't know. Okay. Okay, so notice this is a proportional relationship. It crosses to the origin. That means it is a direct variation. Okay? So to find my direct variation equation, I'm just going to do a y value over an x value right here. 15 over 2. Right? 15 over 2. Y over x. What does 15 over 2 equal? Well, it equals 7.5. So I can have y equals 7.5x. I could leave it as 15 over 2x. Okay? Okay, so I want to know if this is a direct variation. So I'm going to double check I'm going to do y over x for both of these values. 9 over a negative 3, that's y over x, equals what? Negative 3. Okay? And then I'm going to do 6 over a negative 2, which equals, that means it's a direct variation. And that also means I've already found my slope. So my slope is negative 3, so my equation is y equals negative 3x. Okay? On my table, I'm going to check to make sure it's a direct variation. I skipped the zeros. Okay? I'm going to do 3 over 6, which equals... No, it doesn't. It equals half. We're going to say half. Don't be afraid of fractions anymore. 5 over 10 also equals... We're going to say what? Half. 8 over 16 equals? Half. Okay, so my equation is?
Y equals
Half x. Or, oh, this is a good one. Or I can say y equals x over 2. Same thing. Yeah.
No.
Yes. Okay? Okay, going to the back. Let's look at some direct variation problems. Okay, some direct variation problems. Okay, if y varies directly with x, that's just a fancy way to say that there's a proportional relationship. Write a direct variation equation for when y equals 10 and x equals 3. Okay, they've given me my x and y values, guys. All I have to do is write an equation, right? Okay, so I'm going to do y over x. So I'm going to do 10 over 3. It's an ugly number, so I'm just going to leave it as 10 over 3. It's going to be a repeating decimal because it's a third. Okay? Okay, now we get a little tricky here. So now it says if A varies directly with B. If you want to help you, you can replace this. If X varies directly with Y. No, I'm sorry. If Y varies directly with X.
How do you know like they're like?
I have honestly never seen it where they give you A and B or something like that. Okay? I've never seen it. If Y varies directly with X, they always say Y first. That makes whatever comes first, whatever is varying directly is your Y value. Okay? Varies directly is your Y. Write a direct variation equation for when A, which is my Y, equals 1 and B equals 7. Okay? So I'm going to do A over B, or in this case also Y over X, which equals 1/7. So my equation is Y equals 1/7 X. Or I could say A equals 1/7 B.
Last year, our math teacher,
Okay, so if N varies directly with N, N would be my Y, N would be my X. Write a direct variation equation for when N equals 6 and N equals 2, and then find N when N equals 12. So we're adding extra stuff here. Okay, so I'm going to have M over N, which is also Y over X. So I'm going to have 6 over 2, which equals 3. Okay. So my equation is M equals 3 times N. Okay, but I want to know, find N when N equals 12, yes? Okay, so I'm going to put 12 into my equation and do what? Solve it. So how do I solve it? Can you help me? Dividing both sides by 3, which would give me 4. N equals 4.
I just multiplied the ends.
Okay, so the difference between 7th and 8th grade, guys, is that they are wanting you to write the equation and use the equation to solve. In 7th grade for AP, you guys just solved. Okay, now we're writing the equation. Okay, we're writing the equation now. What, Dylan?
For me, I just multiplied the 6 and 2 by 2. Because 6 times 2 was 12, so 2 times 2.
So you're going back to the whole idea of a proportional relationship. And that's fine, but I want to force you to write the equation. When you're taking a test, if that gets you your answer, that's great. But we want to practice as much as we can writing the equation because they're going to ask for the equation too. Okay? So just be careful with that. The weight of an object on Titan, one of Saturn's moon, is proportional to the weight of X of the object on Earth. Okay? An object that weighs 105 pounds on Earth would weigh 15 pounds on Titan. Write an equation that represents the situation. So again, I want to write an equation, yes? What is the weight on Earth? 105. What is the weight on Titan? 15. Okay? So it's actually telling me that the weight on Earth is my X value and the weight on Titan is my Y value. In other words, the weight on Titan depends on the weight on Earth. Right? The weight on Titan depends on that. That's the only way we can figure it out because we live on Earth. Right? Okay? Okay, so now I'm going to plug these into my equation. I want to actually find what my M value is. So we could just go back to Y over X. What's Y over X going to be? 15 over 105. Okay. Now what they want you to do is actually plug in your X and Y value, but I'm going to show you how it's the same. Because to solve for that, I would just be dividing by 105, right? So I still just am dividing Y over X. All I'm doing is finding my slope. Okay? Okay, what is 15 divided by 105? 1/7. Not 7, 1/7. Don't make silly mistakes like that. Because this is 1 out of 7. This is less than the number 1. Okay? Less than the number 1. So my equation is Y equals 1/7 X. Guys, I know I've done a ton of talking today, and this is unusual for me. This is going to happen every now and then in my class. So I'm really sorry. We're doing really great though. Okay? Okay, let's look at our last two examples. A car drives 280 miles in 5.5 hours, assuming that the distance traveled varies directly with the time traveled. Okay, write a direct variation equation. How far will the car travel in 7 hours? Okay, first we need to determine what my X is and what my Y is. Okay, so does miles depend on hours, or does hours depend on miles? So you're telling me how long I drive depends on the miles driven? No, the miles driven depends on how long I've driven, right? Okay. So if the miles depends on the hours, this is my Y. This is my X. Okay? So my Y is going to be my miles, the distance traveled, and the X is going to be how long I've been traveling. Yes? Okay, so we know we can do Y over X. So I need to do what? What is the Y? 280 over 5.5. And I get a really ugly number.
5.9091.
50.9. We're going to round it. So Y equals 50.9X. So wait, I want to know how long it's going to be for 7 hours. What do I do? Plug it in to X or Y. To X. So Y equals 50.9 times 7, which gives me
356.364.
356.3.
Okay. Okay, we're almost out of time, but I can get through these last ones very quickly. And this is back on Canvas. This will be on Canvas, so if this was too fast for you, you can go back and listen to anything, okay? Okay, so tell whether the table is a direct variation or not. If so, write a direct variation equation. So I want to know, is it a direct variation? My y over x should be constant, right? Okay. Okay, so I have 3 over 15, which equals,
No,
no,
what?
1/5. I have 1 over 5, that equals 1/5. I have 5 over 25. Is that 1/5?
Yes.
10 over 50, is that 1/5? Okay, so is it a direct variation?
Yes.
Yes, so my equation is y equals 1/5 x. Okay, and my last one is -8 over -2 is 4. See, I almost did y'all's mistake. 16 over 4 is 4. I'm going to skip the zeros. 32 divided by -8 is
Negative.
-4. Is this a direct variation?
No.
No. So not a direct variation. Okay, so your homework tonight is, or over the weekend, is to work on that puzzle page. Guys, that does not have to be done by Tuesday, let's say Wednesday, but it is kind of long. I think the biggest thing with direct variation is you just need to make sure you can write those equations, okay? You need to be able to see if you can do that, and that puzzle page will help you do that. And if you can do that for like 5 of them in a row, that's probably good, but make sure you do at least a couple word problems at the bottom too, okay?
Yeah.
Okay. Make sure you understand it.
Miss Grace, could you put these up on,
This will be on campus.